My presentation, Schrodinger's backup. How do you know your backups work if you've never tried to restore them? So, who am I? My name is Sean Oden. I started my career as a pilot, became a programmer, then moved on to databases. I've been an amateur geek for almost all of my life and went pro about 25 years ago. I've been a part of the cold fusion community for almost all of that time, and even though I'm not really doing much CF anymore, I'm currently a DBA for the U.S. Army. Today we're going to talk about the backup and restore process. We'll talk a little bit about the history of backup media, what backups are, and why we do them. We'll also talk about the restore process, and I'll tell you about some of the issues that I've run into over the years. Most of what I'm going to talk about relates to the data aspects of backup system, but it's important to remember that it doesn't just include data. Backups also cover software, hardware, files, and pretty much anything. So let's go. Before we really get started, we should define what a backup is. A backup is essentially an alternate means to accomplish your goal. In the computer world, that may mean duplicate hardware, copies of software and data, or other resources that you need to complete a process in the case that you have a failure. About 40,000 years ago, humans carved marks into pieces of bone or sticks to keep track of whatever it was that they were counting. The sticks could be split down the middle to make copies, and we eventually moved on to paper, which could be copied by hand or by machine. And now we're using computers, which have their own ways to make duplicates. We've known for quite some time that it was important to make a backup of our data in case our original copy was destroyed or lost. One unfortunate example of important data being lost involved the 1890 U.S. Census. Every 10 years, the U.S. requires an enumeration of its citizens, and until the end of the 19th century, it was all being processed by hand. The 1880 census took almost 10 years to tabulate. But between 1870 and 1880, the U.S. population grew rather significantly, and for the 1890 census, the government wanted to get a much better idea of who was living in the country. So they asked a lot more questions than they had previous years. It already took a significant amount of time to compile the data, and there was so much more of it. So they needed a better option to process it all. An electronic tabulation machine was invented. This machine used paper punch cards to input and track that data. And since a single punch card doesn't hold a lot of data, that made up for a whole lot of punch cards. But even still, that machine sped the process up from 10 years to just under 6. Unfortunately, in 1921, a fire destroyed most of the cards from that census, leaving huge holes in the genealogical records of many families. This loss very clearly demonstrated the need for backups. Those tabulating machines eventually grew into electronic computers, and the data kept growing. Back in the mid-1950s, it wasn't so easy to manage that data. Storage was difficult and quite a bit bulky. The picture on the left is an IBM 305 RAMAC computer, and the one on the right is its hard drive. It had a whopping 3.75 megabytes of storage space and only weighed about 2,000 pounds. And if you needed to rent that machine for a month, you'd be out about the modern equivalent of $33,000. So the data stored on those drives was pretty important. It's not very convenient to keep a backup copy of a 1-ton drive. Around that time, computer engineers realized that magnetic tapes used for audio recording, which have been around for quite a while, could be modified to use for use with data. So tape storage was born. Data could be copied to and from those tapes, and because it was much more convenient, it quickly became the standard for data storage of the day. Over the years, the technology has gotten significantly smaller and cheaper, and though it's not as fast as more modern solutions, it is still in use in some places today as a very effective and cheap backup medium. Hard drive technology also continued to improve, and as they became smaller and cheaper, they still had a place in the backup scheme. As their size shrunk, their capacity increased significantly, and they allowed many backup operations to be easily automated. And with the introduction and proliferation of home computing systems, hard drives became a viable alternative for backups and took back their status as the standard for data storage. As data needs continue to increase and our backup needs changed, we recognized the need for a quick and easy way to perform backups. Writable CDs filled that void. They were very compact and could store about 650 megabytes of data initially, which was a lot at the time. Plus, they were very portable. One big problem with writable CDs was that at first they could only be used once, and they often had problems with failed writes. So the disk had to be thrown out. They were also very susceptible to scratching and other physical damage that prevented them from being read. Depending on how the disks were stored, they usually have a lifespan that can exceed 100 to 200 years, but some disks can begin to degrade within under 20 years. If you use them for long-term storage, make sure to check them every now and then. Around this time, another tech was jumping into the game. Some of you may remember one of the coolest storage inventions that became one of the most frustrating pieces of tech ever. The iOmega zip drive. A disk can initially store about 100 megabytes of data, so quite a bit less than a CD, but it was reliable. It could be used multiple times. Plus, they were relatively fast. The drives were also relatively inexpensive, but the disks were slightly expensive. But considering the high failure rate of early CDRs and the high cost of hard drives at the time, it was a fair trade-off. And as data needs kept growing, iOmega created new products like a 1 gigabyte Jazz drive and some other larger storage media. They started off pretty strong, but then a couple of things happened. First, rewritable CDs became a much bigger thing than they initially were. And while initially somewhat expensive, they could hold significantly more data than a zip disk. But what really drove the nail in iOmega's coffin was a hardware problem that began to crop up in their devices. The click of death. If you've ever used a zip drive, that sound will probably haunt your dreams tonight. And for that, I do apologize. If you were lucky when the clicking started, you only lost the drive and not all of the data that was on the disk that was in that drive. If the disk did survive, then you had to go buy another drive and try to copy that data somewhere else. The issue supposedly affected a small number of drives, but iOmega initially denied the problem, and its reputation was severely damaged. Sales plummeted. Fortunately, optical storage was making massive strides. Prices on CDRWs were falling, and writable DVDs, which could hold about 4.7 gigabytes of data, were coming on the scene. At first, they were pretty expensive, but now prices are extremely low, and if you purchase a system that has a disk drive in it, it's likely a DVD drive. Their capacity has grown to about 8 gigabytes, and there are now writable Blu-ray discs which can hold around 25 to 50 gigabytes of data. And earlier this year, I read about a new technology, a new method of creating optical discs that can hold up to 125 terabytes of data, which is absolutely insane. But still, nothing beats the cost per gigabyte of a hard drive. Spinning drives are very cheap, and solid-state drives are catching up and are significantly faster. And drive technology continues to make huge improvements. Newer NVMe and M2 drives are even faster still, and they are extremely compact. Though most of the early technology was business-focused, there was a rush of other tech that can easily be used for the home, too. There are all sorts of USB devices for smaller, portable personal storage. There are also some larger options that are very ideal for home backups. Then there's also NAS technology, or network attached storage. It's been around for several years, but technology is becoming very good for home and business needs. The NAS itself is essentially just a lightweight computer with a bunch of drive space that can be attached to your local network and shared across other systems. Different brands have different software and features, or you can even build your own. And with the price of drives falling, they are very economical. They are a very economical solution to your data storage and backup needs. And similar to NAS is SAN, or Storage Area Network. Rather than being a single system like NAS, a SAN is a group of systems like file servers that are grouped together and treated like they are a singular system. They are extremely fast and can have a much larger capacity than a NAS. If we're going to talk about multi-disk storage, we should also talk about RAID. No, not that kind of RAID. RAID is in redundant array of independent disks. It's not really the same kind of solution as the previous examples. It's more of a set of storage methods that we use multiple disks to provide fault tolerance. That doesn't provide a real backup of your data, so it won't help you if you accidentally delete your drive. But it does provide you with a method of redundancy to prevent or reduce data loss if there is a physical problem with those drives. I should also mention a newer option that is everywhere these days. The often misunderstood cloud. There are roughly a bazillion services that operate in the cloud, mostly on AWS, Azure, or Google Cloud Platform, and it seems to be the direction the future is heading in. But what the cloud basically is pretty much just somebody else's data center somewhere else, and they do most of the hard work of backups or stores and redundancies for you. As I said earlier, the data that we have generated has grown tremendously. In the 1950s, when a one-ton drive held 3.5 megabytes, there wasn't a whole lot of data in the world yet. The first 1 gigabyte hard drive was invented in 1980, and by the mid-80s, we only had a couple of million terabytes of data in the world. That's a tiny fraction of what we now generate each day. It took us until 2010 to enter the zettabyte era, where we finally had amassed 1 zettabyte of data, or 1 billion terabytes. It took us another 8 years before we were generating over 1 exabyte of data each day, or 1 million terabytes. And by 2020, we had over 4.8 billion people on the internet. And our total data size had increased to about 44 zettabytes, with most of that coming in just the prior 2 years. Now, with all of our internet security cameras and every device you can think of being smart, like TVs or even my refrigerator, by next year we'll have over 75 billion IoT devices on the internet. And we'll be generating over 463 exabytes of data each day, with expectations to double that every couple of years. At that rate, 2025 will see almost 200 zettabytes of data. Now, humans have proven time and again that we really like our data, and we don't want to lose any of it, of course, which is why we bother with all these backups. But bad stuff can happen at any time, and that data can disappear. We want to be prepared for it. That's where a disaster recovery plan comes in. A disaster recovery plan is a formalized plan for how your organization will deal with a major disaster. We build these plans before the disaster happens so that when it does, we can spring into action instead of fumbling around trying to figure out where to even start. And disaster recovery planning can easily be a full-time job itself. 2 key concepts of disaster recovery are RPO, or Recovery Point Objective, and RTO, or Recovery Time Objective. Simply put, RPO is the maximum amount of data that the organization can tolerate losing. This parameter is measured in time. For example, you've determined that you can lose the last 8 hours of data without a major issue. So you should be taking backups at a minimum of every 8 hours. If you experience a failure now and your last data backup was 6 hours ago with an RPO of 8 hours, you're within your goal. RTO is the goal that your organization sets for the maximum length of time it should take to restore normal operations following an outage or data loss. This is also measured in time. RTO may be longer than RPO, and the clock starts at the time of the failure and ends when the system has returned to normal operation. This will include time to identify the outage, troubleshoot, restore, test, and return to production. This is where testing your restore process really pays off. It allows you to know how long it's going to take you to do the things that you need to do, or at least give you a good idea of it. And then different applications can have different RTOs. We can improve RPO by taking backups more often, To improve RTO, we can implement good monitoring, redundancy, fault tolerance, and automation. Proving both of these will have both financial impact and an increased workload. So it's something that will definitely need to be worked on with the business. Now, what are some of the common reasons for needing a backup? First and foremost, human error is probably the biggest reason that you'll ever need to restore a backup. People have accidents. They may break a network device that corrupts a database update. They may unplug a server right in the middle of a critical software patch. Or they may simply accidentally delete data or files. It's not uncommon to receive a request to restore some lost data from a specific time frame. Having a backup may be the only thing that allows you to recover and return to normal operations. So the first time I spoke at a conference was in 2020 at the virtual end of the box. I was super nervous, and I made sure that I had everything ready to go weeks before the conference. I had just bought myself a nifty new 32 gigabyte super compact USB stick, which I used to build my entire presentation on. When it wasn't being used in my computer, I kept it in my pocket. I had no other copies because I simply didn't think of it. I was really just playing with a new toy, which was kind of stupid on my part. Well, about a week before the conference, I made the horrible decision to clean up my office so that it looked nice for my presentation. You can probably see where this is going. I also cleaned up that USB stick, which I pretty much still haven't found to this day. With about 4 days to go, I went into full panic mode. I accepted that my presentation was gone, so I set about rewriting the whole thing, and I finished it up the morning before I was scheduled to speak. And when it came my turn to talk, I was a bit sleep deprived and kind of out of it, but I made it through it. Surprisingly, orders selected me again the next year, and I came prepared. I had a copy of my presentation on the laptop I was presenting from, a copy on the backup laptop that I brought, 2 copies on 2 different USB sticks. One was in my pocket, one was in my backpack, and a 5th copy on my Google Drive. And since I had switched to Reveal.js for the presentations, I technically also had a copy of the source on GitHub. That was probably a bit overkill, but I really wasn't going to take any chances. Now, if you've worked with computers for any length of time, you know that things sometimes break on their own. While it may be expensive to keep backup devices on hand, it may not be a bad idea for critical operations or even very important data that you don't want to lose. So how many of you have a Plex server at home? I had about 4 terabytes of movies that I'd spent hundreds of man hours over the previous few years ripping from my DVD collection. Modern hard drives are able to monitor themselves for problems and do a good job of letting you know when something's going wrong. Make sure to listen to them. My movie drive started to display errors, but I just kept telling myself I'll back this stuff up tomorrow. But before tomorrow ever got there for me, my drive died, and I wasn't able to recover any of my files. It took me an embarrassing amount of time to rebuild my missing movie collection, and I still have some that are just gone now. It would have been so much easier if I had just bought an extra drive and backed them up to begin with. That definitely wasn't a fun lesson to learn. Now, since we all write perfect bug-free software, we never really have to worry about this next one, right? It's kind of the same thing as human error, because software only does what a programmer tells it to. But have any of you ever pushed code to production with an update query that you forgot to add the where clause to? I mean, oops. Now, bad configurations is another one that can also be human error, but sometimes the wrong settings can cause unexpected corruption or failure. And I would also add encryption issues into this category. It's a really bad day when you've got the wrong encryption key for the data that you need to restore as fast as possible. Sadly, this next group is on the rise. Cybersecurity incidents happen about once every 39 seconds, with ransomware attacks being a large part of attacks. They affected almost 73% of organizations globally in 2023, with the average cost of recovery being around $1.8 million, plus an average $4.5 million in ransom payments. Even if the companies do pay the ransom, very few organizations ever get their data back. And there's a strong press by many governments to prohibit ransom payments in the first place. You'll want to be prepared to recover your own data should that need arise. You really need a good backup plan. So, and there's always good old Mother Nature. Despite our best efforts, she still can't be controlled. Earthquakes, hurricanes, tornadoes, and rain can all easily stop your business in its tracks. And let's not forget that we're currently approaching the peak of the 11-year cycle of solar activity. So when something breaks without an obvious reason, it's always been funny to blame sunspots for the trouble. But as we've seen very recently with calm outages and some minor damage around the northern hemisphere, it's actually a very real concern. Basically, with everything that can go wrong, if you can't afford to lose it, back it up. One good method to keep your data safe is to follow the 3-2-1 backup rule. There are many different takes on this, but essentially it states that you should have at least 3 copies of your data. One is the production data, then 2 copies of that data, preferably on 2 different types of media like disk or tape, and then you keep those 2 copies at different locations. Probably one locally on site for easy, quick recovery, and then 1 copy offsite, so that if Mother Nature does decide to show you some extra attention, she isn't likely to take out both of your backup copies. This is where cloud solutions really come in handy. Now, there are 3 main types of backups: full, differential, and incremental or transactional. Full is a complete backup of the entire system. This type of backup is the slowest to complete and requires the most space, but it is the fastest and least complicated to restore, since you only need 1 file. Though because of the necessary infrequency, they may result in significant data loss. A differential backup works in conjunction with the full backup and is a partial backup of any changes that happened since the last full backup. There can be multiple differential backups in a cycle, but you only have to restore the most recent one, since it goes all the way back to the last full. Since these aren't a full backup, they are much faster to take them to full, and they are smaller, even though they do grow after each successive differential backup. But they do require the full to be restored first. They will lose any data that was inserted after the last differential backup. Now, if you have a system that you can't afford to lose any data, then you probably want to go with an incremental or with transactional backups. This type of backup still requires a full backup, but you may or may not need a differential. However, since an incremental backup includes only the changes since the last backup of any kind, they are very fast to take. They're small, but they are the most complex to restore. Since to restore an incremental backup, you have to restore the last full, then any differential if there is one, and then each incremental in order. Because of their complexity, these take the most time to fully restore, and it's easy to make a mistake if you aren't paying attention. Since these backups are usually done on a very short schedule, your data loss may be very minimal. Now, some systems allow you to take a snapshot backup, which is a moment-in-time backup of the system that may or may not be running. These are most commonly associated with entire system restores, especially when using virtual machines. They work great for almost anything and they're very fast to get an entire system back up and running, but they can cause synchronization and corruption issues on databases that are not done properly. When it comes to databases for disaster recovery, it's usually better to use the backup methods of the database itself. Snapshot backups can be incredibly fast, but they are very similar to incremental backups. They still require an initial snapshot to be able to restore any of the subsequent snapshots. And depending on your software, some may function like a full backup, where they take a full backup each time, which would result in a lot of space. And then some may take shorter incremental or transactional type backups. Then there's also the mirror backup, which is essentially just a running copy of a running system. It's exactly like your current production system and will provide the least amount of data loss, if any. If your primary system fails, you just switch to your mirror while you fix your primary. However, this isn't really a backup as much as it is just redundancy. If your problem is corruption or deleted data, you may be out of luck if that change was also completed over in your mirror. Again, the backup strategy you need will be very individual to you. But for most systems, Your most important data should be backed up with a full backup at least weekly or maybe daily. If you have data that rarely changes, a monthly or weekly backup may be more appropriate. But if you have transactional data that changes very often, you may need to perform a backup every few minutes or so. It will all require analysis of how much data you can afford to lose. One rule of thumb is that the faster it is to back something up, the slower it is to restore it all. But slow, full backups require the most space. It's all a balancing act. And after you've got all your data backed up, don't forget about security. You should limit who has access to backups, and if you have protected data in your system, like health or personal information, you should definitely encrypt that backup. Treat it no different than your production systems. Stolen backups are a very common way the data breaches occur. But also don't forget to back up any encryption keys that you use on that data and on those backups. Then keep those encryption keys somewhere offsite or away from your data and backups so they can't easily be stolen or lost. But make sure that you can still get to them if you need them to restore. And depending on the types of data you have and the regulations or rules you operate under, the amount of time that you keep your data uh, and your backups can change significantly. Some policies may only require a few days, especially if you're space limited, but some regulations may require you to keep that data for years, so you'll have to plan for that sort of retention policy. It all really just depends. But just remember that it's much more difficult to steal data that you no longer have. If you're breached, it's best just not to have old stuff lying around that you just don't need anymore. Get rid of it. Now, so you've done all the work of setting up a good backup plan. You're good to go, right? Well, you aren't quite done yet. If you're doing those things, you're better. You're a much better place than most. Only 10% of people are doing backups daily. Only 15% are doing backups weekly, and then only 33% are doing them monthly. That leaves around 40% uh, that rarely or never do backups, and that's not good. Especially when you consider that in 2022, about 76% of companies suffered downtime because of data issues. And about 72% of all users had to resort to their backups to recover that data, which means that a lot of those people had a lot of data loss. Also, backups fail about 43% of the time, and restores fail about 39% of the time. Getting back all of your data only happens about 25% of the time. That's really not good either, especially when you look at the fact that data loss often results in business failure. Out of the businesses who suffered a large data loss that lasted longer than 10 days, 90% of those businesses closed their doors within a year, and then 50% closed almost immediately. Don't forget that the entire point of backups is to be able to get back up and running ASAP with hopefully no data loss. But also don't forget that the main part of the backup is being able to restore that backup. A restore is what we do after the failure. We take our backups and we copy them back to their normal or their original location or a new location, and then that allows us to return to normal operations with minimal downtime. But don't forget that restores fail almost 39% of the time. So a few years ago, I did a large migration of several databases. The first one went fairly smoothly. I got the new server installed. I backed up my original database and moved over to the new server. But when I tried to restore it, it failed because it was an encrypted database and I had my key. I was luckily able to back up the key on my source database because I still had it running. Then I moved it over to the new one and I got everything back up and running again. I made sure to document that step so that I wouldn't forget it the next time. And I was really fortunate that SQL Server told me that I was trying to restore an encrypted database with the wrong key. Now, on the next server that I did, I followed the same basic steps. Back up the source, I moved to the new server, I restored the backup. But when I made some additional configuration changes, I really borked my database beyond all chance of salvage. Now, that was no problem. I set the database to be backed up every night. I could just restore the backup so that at the very least I'd only lose my day's worth of work. No biggie at all. until I went to grab the backup and discovered that while I had set the process up, I hadn't turned it on. So I had no backups. Now, while that was extremely embarrassing, I figured I could fix this too. I forgot to take a snapshot before I began, but I finished it. But I just talked to my virtual machine guy and had him restore his snapshot that was scheduled to be taken from the night before. I'd still only lose about the same amount of work. And that was when we found out that we hadn't turned on the backups for that either, the snapshots for those either. So after he rebuilt the server image for me, I reinstalled all the database software, rebuilt the databases, and immediately took both database backups and a VM snapshot. Then I made sure that both processes were turned on. Then checked them again the next day to make sure they were still working. And this is why we test. We don't know if a restore will work unless we test it first. And a restore definitely won't work if we never took a backup to begin with. Always test and verify your backups. So, how can we test? A failure is going to be stressful. Everyone will be yelling to have it fixed right now. And running through regular tests will make sure that we can get the people to stop yelling as quickly as possible. Our first step is to make sure that we know what our process is supposed to be. What kind of backups did we take? Will we need to restore multiple files? When did the failure occur so that we know which files we need to start or restore with? And do any of our backups contain the failed or corrupted data? We may not be able to use those. We should simulate those scenarios during our tests so that we know how to handle them. Now, before we start our test, we want to make sure that we have the resources to get the restoration done. Do we have a test system that is set up as similar to production as possible? And does it have enough space? This step can be very expensive, but it is also worth that cost. Also, is our test system isolated from our production systems? Will our restore scripts or processes that we are testing do the restore in the right place? It would be very bad just to restore, only to find out that we're restoring back into our running production systems. And then practicing the restore will give us a good idea of what our RTO can be. If we know how long it's going to take us to get the restore done, then it's much easier to get people who keep asking, how long will it take? To let you do your job if you don't have to tell them, I don't know. So I once worked for a company whose primary application relied on the files in a 40 billion file server. We came in one morning to a massive motherboard failure that had taken out that file server and our critical operations with it. We had to order a new motherboard, which took a day to get to us, and then had to rebuild the RAID array that the file drives were set up with. And then we had to watch for the next 2 days as files slowly came back online as their proper permissions were reapplied. We were partially down for most of a week. If we had thought to test that kind of error, we would have been better prepared and done things a lot differently. So after your test is complete, do a check to verify that the data you restored is correct. If you have an automated testing process, run that. Just because you didn't get any errors when you put the data back doesn't always mean that the restore is successful. At least spot check your apps. And then automate whatever processes you can. It's easy to forget steps, and the automation helps minimize those missed steps. Also, don't forget to monitor your automation after you turn it on. And then make sure to document the steps that you took to do all this. Make it easy for yourself or for whoever it is that has to do all of this the next time. And then keep testing those restores. Not only will you need to keep testing as you keep doing backups to make sure those are good, but the more times you complete a restore, the better you'll get at it. Practice makes perfect. And so now that we've gone through the entire process, from a complete backup to complete and test to restore, then we can be fairly certain that we actually need to open our box of backups. They'll be alive and ready